Alright, so this is a linear voltage regulator circuit which I had made from very simple components and the LM317 IC. And when I increase the potentiometer, the LED starts oning, and when I decrease, right here, this is the LM317 IC with an heatsink attached to it because it produces a lot of heat during the process of voltage conversion. And I have used an LED to indicate the voltage. I have connected the 5V supply so near to the input. When I place the multimeter, as you can see, the input is 5.03 volts, but right at the output LED, when I place the multimeter, the voltage varies from 1.2 volts to 4.1 volts. And instead of 5V supply, if I provide 12 volts to it, then the output voltage can vary till 11.8 volts to around 1 volt. So right here I have used an LM317 IC, which is a linear voltage regulator. So this is the pin diagram of it, where this is the pin out of it, where this is the adjust V out and V in. So right here I have used this LM317 IC and have placed an heatsink because during the process of input to output voltage conversion, it releases a lot of heat, and have used two capacitors and an 10K pot so that I can vary the spin resistance based on which it will provide me the output voltage. Let's talk about this circuit diagram. So this is used to control the voltage. Also, the LM317 can also control voltage and current, and this circuit is specialized to convert the voltage. So right here I am providing the input voltage and have attached in parallel a capacitor of 0.1 microfarad, and right here this is the LM317 IC, and have used a 10K pot and a one resistor to limit the current of it. And I'm going to be taking the output voltage right from here. So basically what happens is, when the input voltage comes in, the LM317 converts it to variable voltage according to our needs, and that excess voltage which is being converted, which means the difference of that voltage, that is taken out in the form of heat. So that is why I had placed an heat sink for the LM317. It can take the input voltage from 0 to 40 volts and produce the output voltage from 0 to 35 volts, and it can provide a max current of 1.5 amps, so which is quite good for this very basic circuit for our daily uses. And if you found anything informative in this video, then make sure to subscribe the channel, and thank you for watching. See you next time.